Right, okay, the stack. One of the most important data structures in computer science. Okay, used for lots of different things. So, things that you could have said, the obvious ones, we use it to store registers. Oh, hang on, where's my thing gone? My whiteboard's gone. Why did that go like that? Oh, I don't know. I clicked the wrong thing. Right, so the obvious things is we store registers, we use it to temporarily save registers, program counter in the CPU, so when we call a subroutine or handle an interrupt. It's also used for passing parameters to subroutines. It's basically a remembering system, the stack. Okay, so if you've had saving registers, storing the program counter as a return address for a subroutine or a function, or when we deal with an interrupt, they're all valid ones. Okay, passing parameters. You can start getting into more algorithmic things like saving locations when you're trying to navigate a maze. So every time you get to a junction, you'd save the junction and what direction have I got left to explore. Anyone got any others? The main ones are the saving registers, passing parameters, storing return addresses. They're the main three. Okay. So the main ones are storing registers at CPU level, storing return addresses, so the value of the program counter when we call a subroutine, storing the return address when we have to handle an interrupt as well. So you know the fetch execute cycle, when we go check for interrupts, if we see one, we have to go, ooh, save the PC, go off and do. And then when we finish the interrupt, we can come back and restore the PC. And then the third one is passing parameters when we call a subroutine. So when you say print and then you put values that you want to print, you're actually passing memory addresses onto the stack. Okay. Right, question 2 and 3. It's really hard to ask these questions without using the word. Right, the adding to a stack is obviously push. And removing from the stack is obviously pop. Push and pop. I have seen on exam questions where they've used the wrong terminology. But there you go. So just be wary. Always read questions super carefully. Right, okay, question 4 then. So code that is going to allow you, I couldn't say push, so I had to wangle on about this. Attempts to add an item to the stack. Right, so I've said write a function that accepts a parameter, an item parameter, so I've given you a name. So your first job, whenever you're asked to write a function, is you're going to do something like this. You're going to say function. You're going to come up with a cool name for it. Now we know a cool name for it. We're going to call it push. You could have called it add, because that's what they asked you to do. Okay. The parameter you need. So you're going to get a mark. So there's one mark for at least writing a function skeleton. And obviously end it or put end function or something. Whenever you're asked for a procedure or a function, you will lose marks if you don't format it as a procedure or function. If they ask for an algorithm, then they just mean a fragment of code. Right, so that's one mark. Nah, not necessarily, but just for your own sanity's sake, you mark it where it stops, that's all. As long as you've got the skeleton at the top. That's the important bit. Right, so this is for pushing. Okay, before we push, we've got to check something. What have we got to check? Pull that down, then I can hear you. Go on. You've got a what? If it's not full. Yeah, if it's not full. Yeah. This is so hard being able to hear everyone. Right, we have to check to see if the stack's full. Now, because this is an algorithm and it's pseudocode, we're not saying exactly how that is, but we need to do something programmatically. So I could say if stack not full, or I could say, which might be better, is if I say, assuming we've got a stack pointer, or something like that. The stack's less than max. It's probably a nicer, codey way of writing it. So if that's true, if we're less than, then we need to add the item to the stack. Stack is generally stored in an array structure or something similar. So I would say wherever the stack pointer is, put my new item. So I'm going to get a mark for doing the correct if. So saying like the decision is the stack full? How you formatted it is fine. Okay. A mark for putting it at the current stack pointer. And then a final mark, because this was out of 4, for putting an increment of the stack pointer. Okay. Now, I didn't say return an error message. I never like that when the example do that, because I think that's silly. But we don't attempt to put something on the stack when the stack is full. If you're going to put else stack full, that's fine. Okay? But the 4 marks were for those 4 stages. Skeleton, because that's what you were asked for. Checking to make sure stack's not full. Adding the item at the current stack pointer, incrementing the stack pointer. So that's your 4 marks. Okay, the second function was to remove. So again, it's a function, and I'm going to call it pop. No parameters required, remember, because you're just accessing the top of the stack. So you get a mark if you've correctly formatted the start of your function skeleton. I'll just scroll that up so you can see. Right, what do we need to be careful of before we try and remove something from the stack? Yeah, check it's empty. So if we can do that quite nicely, because we don't have to introduce any extra values, we can say if the stack pointer is greater than 0, so that's our check for empty. Then we can actually try and remove our item. But what we've got to remember is that when we've got a stack, the stack pointer always is pointing at the next free space. Now, that's not to say in an exam question the exam board might try and do it completely differently, but they'll have to explain how it works in their example if they're going to change that. But generally the stack pointer is set up to point at free space. So once we've determined that the stack isn't empty, then our first job is to decrease the stack pointer. So we need to do something like that. You might have written it in long form, you might have put SP minus equals 1, or you might have gone real old school and written SP equals SP minus 1. All the same. Okay, as long as you're decrementing the stack pointer, it doesn't matter. It's the logic that they're interested in. Right, then we can return our value. So we can then say return, so you get a mark for the decrement, and then it's going to be whatever you call your stack. You could have called it list, array, it doesn't matter, but I would call it a stack. Okay, but you do not return until you've decremented. Now it's pseudocode, so yes, this isn't going to stick to any rule of any language because we're not using a language, are we? So that might actually work in a fair few languages. Some languages they're going to go mad if you do that, okay, because they'll say not all values, all paths return a value. But that's an implementation issue. Okay, so again, that was out of 4 marks. And if we do that operation, the stack pointer will be there. We'll have retrieved the 40, and if we come to push something, we just overwrite that location and move the stack pointer on. Okay, stack pointer fundamental, super quick operation. I've written loads of code where I wanted something to work as fast as possible, and I've nicked the stack in order to push data around in memory. Okay, it's a standard technique on low speed hardware. Okay, can you total that up? It's out of 13.